Hello, I hope things are going great for you at home. We're chugging through another week. Today's math task on MathSpace is we're going to be doing story problems with multiplication and division. So what students do, what happens with students is they get really good at multiplying and dividing, but then they forget when it comes to a story problem whether they're supposed to multiply or whether they're supposed to divide. Because if you divide on a story problem when you're supposed to multiply, you'll get it wrong. And if you multiply when you're supposed to divide, you'll get it wrong. Just like if I'm at the store and I'm trying to, buy groups of things, if I divide my numbers, I multiply the amount of money that I've calculated will be off. So we want to be accurate because that's how we can be efficient in the real world. So one thing about MathSpace is that it doesn't really have any tasks that are very well done for the regular algorithm of division, which is really a tragedy because the regular algorithm, the one that I learned, the one that we really hammered hard in class, the one that your parents know, it is a very efficient way to divide. We've done area models for the last few days, and you can do area models up to as many digits as you want. The principle still applies. You take away multiples of tens and hundreds till you get to the basic fact. So today I'm going to show you a little bit of the regular division algorithm, so you can use that on today's division problems if you would like. And then I'll also do a little bit of just talking about how to think about multiplication and division story problems. So I have my algorithm. Let's say I do dead monkeys smell bad. Remember touching on that in class. So let's say I'm doing 862 divide by 7. I'm always going to follow my steps in this order. Remember, it stands for divide, multiply, subtract, bring down. Dead monkeys smell bad. So my first step is I say 7. 7 goes into 8 how many times? Or how many groups of 7 are there in 8? Well, if I have 1, 2, 3, 4, 5, 6, 7, 8, I can make one group of 7. So that's when I say it goes into, it just means how many multiples of 7 are there in 8, or how many times could it go into it as a group. So 7 goes into 8 one time. Check. I just did my divide step. My next step is to multiply. I'm going to multiply this number on top times the number on the side. So 1 times 7 equals 7. And I'm always at first just very, very careful, very super, super careful to follow these steps. My next step is to subtract. 8 minus 7 equals 1. Check. And then the B means to bring down. So the number I bring down is the 6. And I just bring down the one number next door. 7 goes into 16 twice. So that's my divide step. Or that's 7 goes into 16 2 times. Then I multiply 2 times 7 equals 14. My next step is to subtract. 16 minus 14 equals 2. And then my next step is to bring down this 2. So I go back to the top. Now I divide again. 7 goes into 22. 3 times 7 is multiplies my next step is 21. Now I subtract. And I don't have anything left to bring down. So that means I'm done, but this one is a remainder. So 123, remainder of 1 is my answer. Now remember, remainders are only something when we do like division problems. In real life, there are no remainders. You have to do something with the remainder, whether it's add it to the quotient. Sometimes the remainder is your answer. Sometimes just your quotient's the answer, not the remainder. Remember that stuff, but today we'll just talk about, we'll have remainders in there. So the way we were doing it yesterday, let me just kind of provide some compare and contrast with the way we were doing it yesterday versus the way we're doing it today. We just did, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 calculations. And the hard thing about this algorithm is that you kind of just have to learn the structure of where it goes. Now with yesterday, we probably, with our squares and boxes, we did a lot of calculations. We probably did like 4 or 5. Well, we probably did like 8 or 9 instead of 11 for problems like these. But the benefit was that we were only dealing with hundreds and tens. So there's a lot less room for error. But just kind of some food for thought of division's just messy no matter how you do it. If you're using the regular algorithm, it just gets messy. You have to be very precise. If you're using the square method, it can get messy as well. So either way, it's just messy. We just have to practice it until we just get proficient enough at it that we know that we're doing it correctly. So let's try another one. Let's do 597 divided by 5. So my first step is 5 goes into 5 one time. That's my divide step. My next step is to multiply. So I'm going to multiply 1 times 5 equals 5. My next step is to subtract. So 5 minus 5 equals 0. And then I need to bring down the 9. 5 goes into 9. I'm back up to my divide step. 1 time. 1 times 5 equals 5. That's my multiply step. Now my subtract is I subtract 9 minus 5, and that equals 4. Now I need to bring on down the 7, and I go back to the top. Divide. 5 goes into 47 9 times. 9 times 5 equals 45. I subtract, and I get a 2. Do I have any numbers to bring down? I don't. So my answer is 119, remainder 2. So thanks for watching those two. I want to talk just for a brief second about how you know whether a number is a division problem or multiplication problem. Okay? When it's a multiplication problem, it's when we have groups of something and we're trying to get a whole. Right? Just like with addition, how we have smaller numbers that we're trying to add up into a whole. That's what multiplication is. So if I were to draw a picture of that, we would have like, let's say these are each 5. So each of those, I'm putting these arrows, all these 5s are combining to equal 25. Okay, because I'm having a set of smaller amounts that's trying to combine to equal a bigger amount. But with division, it's going the other way. With division, you are starting with a whole. You're starting with a whole amount, and you're breaking it down into groups of something. So instead of all these 5s combined to equal a single 25, the arrows are going the opposite direction. The 25 is going to break down to equal groups of 5. So they are the same. They're very related. It's just which direction the arrow is going. So something to ask yourself when you're doing these story problems today is it giving me parts and then it's asking for me to find a total? If the answer to that question is yes, then it's a multiplication problem. You need to multiply those groups of numbers to get your answer. However, on the other hand, if it is starting with your whole and it's wanting to break it down into groups, then it's a division question because you're starting with a whole number that's wanting you to break it down into groups. So it just depends. Are you trying to find the number of groups of something, or do you have the number of groups and you're trying to find a total? So I'll say that one more time. If you have groups of something and you want to combine those to a total, then it's a multiplication problem. And if you begin with a total number or a larger number and it wants that larger number to break down into smaller groups, then it's a division problem. So thank you so much for watching. Keep working hard and keep up the good work. Thanks very much. Bye-bye.